Trying to. All right, I think we're back live. We're streaming into the Zoom lobby. It's 11 a.m. and I think we'll get going. So we are here. We have the pleasure to be here with Tom Brinkoetter, who's a wireless tech expert with extensive hands-on experience running all types of electronic test equipment. He believes that drone-based measurements can help wireless site managers really significantly improve the performance of their system. So we're here today to listen to Tom's observations of his work in the field on new developments and using drones to listen for radio frequency interference and EMF exposure as well. So welcome aboard, Tom. Pleasure to have you.
Yeah, I'm going to hit share screen here.
Absolutely.
Is that one? Is that being shared?
It is.
Very good. Thanks for Joe for inviting me again to give a presentation at the NSMA conference. So I'm retired, as Joe said, from 40 years of test and measurement, and was a business manager and engineer for RF test products. So in my role with these corporations, I was responsible for looking at and assessing trends, and I was pretty early to see the potential for drone-mounted spectrum measurements, and that's before these drones came about. So once the FAA 107 license came available, I went out and got that. I've been taking the test now for 3 years. I take it again this fall. You have to take it every 2 years. So I've been experimenting and making measurements with drones now for the past 5 years. And I think at this point, I'm a evangelist for drone-mounted spectrum analyzer measurements. So this presentation is an update from the presentation I gave at last year's conference, and I hope to convey how rapidly this market is progressing. I saw so many changes in the last year, so it's clearly a new world. So some of the topics I'll go over: why would you go to all the effort to mount a spectrum analyzer on a drone? I'll talk a little bit about the FAA rules, do a brief overview of the equipment that's needed, give a couple example problems, customer solutions that I've worked on, and then talk about some new drone stuff that I've seen in the last year, compare using a drone to legacy solutions, and do a summary. So why elevate spectrum measurements? Well, you get to see what your antenna sees. You get line of sight to the RF source. For interference hunting, you get away from all the bad things on the ground, like multipath and inverters and other people's cell phones. So there's a lot of advantages for the interference world. For the new world of 5G, most of the stuff today is line of sight. The path loss is well known with the Freeze equation, and you can do signal strength studies if you can get up into the path of the energy. So the propagation, we're lost here. So the recent developments in 5G is to move transmitters down to the street level, closer to where the humans are, of course, and that increases their concern for RF exposure. But now both the need to make measurements and the physical difficulty to do the measurements is increasing. So a drone-mounted spectrum equipment is a nice, ideal solution. I'll talk a little bit more about that later to get in the path of those emissions. Of course, the FAA manages all aircraft, including these new drones. In 2016, the FAA introduced the 107 program. Before that, you needed a full pilot's license. And the FAA has been changing the requirements. It's good that they're testing every 2 years, because the requirements are changing pretty quickly. Some of the things that are locked in, an FAA 107 pilot is limited to 55 pounds, which is a lot of weight in the air, frankly. And you need a license if you're doing anything for any revenue or any business related stuff. You need the 107 license. If it's truly just for fun, you can go under the recreational, but you still have to register your drone with the FAA. Some of the rules: You have to have your eyes on the drone at all times, and that actually is quite tricky. You can't fly over people. There's some waivers for that, but you need really very complicated equipment to have parachutes and stuff to keep stuff from landing or crashing onto people. 3-mile visibility, that's normal aircraft visual operation. Waiver for flying at night. Flying in improved airspace, that's changed a lot in the past 5 years. Used to be, you had to be further away than 5 miles from an airport. And now you can use an automated system with an app to find out if you're able to fly there. Hardware overview. Of course, for the applications we're talking about, you need to lift a payload. This is not the consumer real estate photography kind of drone situation. So the first thing is, can the drone carry the analyzer? And the FAA isn't going to look at what you're doing. They count on the pilot in command to make good decisions, mount the equipment right so it doesn't fall off or cause the drone to crash. So then of course the larger drones have payload specifications, and you need to be sure you're following those requirements. So at the drone shows I go to, I see a lot of crazy things people are doing. Drones, everything from planting trees, crop dusters, cell sites that pop up and stay up for weeks with tethering. DJI from China is the leader in drones with probably about 70% share. And their cameras are unmatched, and their inertial management system to keep these things stable, I think is pretty amazing. And I know some users, military telcos, are nervous about Chinese. After John's last presentation, I was nervous about talking about having Chinese drones, but they're amazing. I have to say, I've flown both kinds, and they're ahead at the moment. But anyway, in the last year, a number of U.S. manufacturers have popped up, and I think the U.S. is going to catch up. Let me get back here. Okay. So I have two commercial drones for my work. A DJI Matrice 600 is
So
legs go up out of the way for
hey, Tom, do you mind repeating what you said for about a minute? Your internet froze for a bit. So if we can
see that. Is it back on?
Yeah.
So let's see how far it was. So I have two commercial drones for my work, a DJI Matrice 600, capable of lifting 14 pounds. That's shown in the picture there. And the legs fold up normally for the camera for Hollywood work. And I've defeated that and keep the triangular pad down there, and I have a nice landing, a nice platform that I can mount analyzers on, and makes it very stable. In a hard landing, the legs won't go up and crush my very expensive test equipment. Let's see. So a couple examples of customer situations that I've solved with the drone. One was an interference situation in Northern California. The terrain was very hilly, and the signal from the interference was getting to the 700 megahertz P25 site up at the 150-foot tower, but they couldn't get it on the ground even with a good high gain antenna and a spectrum analyzer. So I brought my drone in. First, we verified the signal on the ground using their receive coupler. And then I set up the same settings and flew the drone up just above their receive antenna. And I was able to get a good bearing, and that got them off to find the interference, and end up being a bidirectional amplifier in a nursing home, as usual for these public safety things. But there's a case where the terrain was just right, where the interference got to the tower, but wasn't you couldn't get it on the ground. Another one, again, public safety, Northern California, UHF system. They are shared on a tower. Their antennas are the long sticks. There's a long stick on the left, so-called collinear, and then there's another one on the top. And it's crazy, just 5 miles away at the police station, they couldn't hear the 50-watt transmitter. The stuff, of course, you would have expected that, but the terrain, again, there was a hill in the way, but they expected it to work. So we took a look at the antennas. The antennas weren't broken. We thought maybe one of them was damaged, and then used the drone to transmit. In this case, I used a much smaller drone, transmitted from the drone, received in the shelter with a bench spectrum analyzer. Plots are on the lower right. Those are the signal strength versus altitude. I wasn't able to fly a circle around this tower because it was on the corner of 4 people's property, and I only had permission from one landowner in the direction of the police station, fortunately. So I could only fly a vertical stripe. So that's what those plots are. Their signal strength versus my altitude. And the notch, the first notch on the left, is intentional. It's where I was horizontal with the antennas. Of course, there were 2 antennas, one transmit on the side, easy to see there, and then the receive way up on the top. And we expect to, when I see these antennas that are broken, you see an up tilt where you're putting more power up into the sky than you are on the ground where it should go. What the surprise was, the strength of the antenna, identical antenna, from the top of the tower was 5 dB stronger than on the side. And what it appears is that antenna is mounted too close to the tower, so there was a notch in the horizontal pattern. So it's something that now looking back on it, okay, yeah, but until you get the drone up in the air and you see what's going on, you're guessing and guessing and guessing. So it really solved the problem for them. So here's a new kit that I'm seeing a bunch of new solutions. Here's a spectrum analyzer vendor out of Latvia. They make point-to-point microwave systems as well, and they make spectrum analyzers to support those installations. And they now have a drone system with 3 of their analyzers on it that can do surveys, spectrum surveys, all the way from 9 kilohertz up to 50 gigahertz. So that's new in the last year. This is two companies that partner together. Epic Solutions, it was a military contractor that did this tiny little spectrum analyzer. It's smaller than your hand. It's smaller than a pack of cigarettes. A 6 gigahertz spectrum analyzer. And the new drone out of Mississippi, the Whisper drone, and they're partnering to do spectrum surveys, mainly for cell. This little analyzer also decodes all the cell signals to give you the transmitter identification, the sector and tower information. So very helpful for doing surveys. I've been working on a similar thing for drone services company, and we ended up using a very powerful scanner from PCTEL, and we mounted it on a FreeFly Alta. It's US made, that has 10-pound payload. So that will be what we will use to do spectrum surveys. Very powerful scanner. So another emerging application, Wi-Fi 6E interference hunting. And I think you've already heard presentations about Wi-Fi 6E, but a little bit about it. So there's a whole new band from 5.9 to 7.1 for Wi-Fi, and that's going to really enhance home and office users with much faster speeds. But of course, there's 10,000 legacy fixed point-to-point links in this frequency range, and they're nervous about interference or noise floor going up from hundreds of Wi-Fi access points being all around them. So these antennas, the systems or the point-to-point links typically have antennas at the top of towers. And the choice would either be to climb the tower with a spectrum analyzer or to have a drone pop up and do the same measurements. So I see this as a opportunity for me, if you will. And I've been evaluating analyzers that's shown here. This my Matrice 600 again with a 14-pound payload, horn antenna, and a analyzer that I found out of Germany that can be extended to 8 gigahertz. Most of the little smaller analyzers that of course I have to choose them for weight, not just for performance. And most of the smaller analyzers stop at 6 gigahertz, most of them. And this one can be extended. The only problem I'm having with it is that it takes a real i7 computer to run it. Now that adds a lot of weight because I have to fly a powerful computer. So it's really a challenge to get the horsepower you need and keep the weight down so that the drone is stable and secure. I'm seeing a lot of change here at the government level. Of course, there's numbers of solutions for monitoring spectrum to be sure licenses are followed or national security is being maintained. And generally, these are fixed systems or at the most mobile vehicle systems. But I've seen a request to support extending the mobile with a tethered drone system. So put a spectrum analyzer on a drone and tether it down, and then send the IQ data down to the ground to the mobile or fixed stations.
Tom, on the tethered drone and the 6 gig, there's we're gonna have a panel on this, and Ira Keltz talked about this earlier this morning as well. Are you able to give an estimate as to what could be measured in terms of unlicensed outdoor and indoor 6 gig and its potential for interference into incumbents? And would that, with the drone system, would that be a tethered drone or a fly around drone or a combination? How would that look?
Well, I think for interference hunting for the 6E, that isn't a long-term measurement. You're going to pop up, you're going to find what you find in the first 30 minutes, and I think you're done. The tethered drone, what I think would be for continuous monitoring, you're going to stay up there for 24 hours or more, and you're going to be looking at the spectrum, just like you would, like you see these vehicles here, and they're doing that with these vehicles, and the drone just gives you a 400-foot tower, which you can't do a 400-foot tower very easily. So it's much of the same things you would see on the ground or with vehicles, but you now have a 400-foot tower.
Yeah, because there's talk of, or not talk, there's plans to deploy, hundreds of millions, if not billions, of these unlicensed devices. And so there's a healthy debate about how to assess if there's going to be harmful interference. Sounds like this might be a tool drones might be a tool to
well, it helps. I mean, you certainly could have a climber climb a tower with a spectrum analyzer and sit there where the system is and make the measurements. But that's it's a trade-off. Do you use a climber or do you use a drone? Drone could be faster. Certainly if you have more than one tower, you can move around quickly. I think certainly rotating 360 degrees, is much easier on a drone than it is when you're climbing on a tower. So, the mobility of these things is amazing. So that's one of the advantages.
Great, thanks.
Okay. So another new application that I've run into in the last year is wildlife tracking. And where am I? Back up here. And of course, wildlife management agencies have been putting radio collars on all manner of animals for years, including frogs and bats, believe it or not. Somehow they're able to get a little transmitter on them. And they use, as you see in the upper left there, receiver and directional antenna to hunt them. And clearly, a drone with 400-foot altitude is going to do it better in a forested environment than being on the ground. I'm heading up to Montana next week to do some more wolf hunting. This will be the kit I'll take up there. It's a Matrice 300. Those 4 props instead of the 6 I have in my other one. These little beacons are UHF 220 megahertz, so that's a 220 megahertz 3-element Yagi. And I'm flying a little signal hound spectrum analyzer and an i5 tablet, and watching the displays on the ground as I rotate the drone and get the direction of the beeps. They're short little beeps, so you have to do some work to get them there, because the collars have to last a couple years. It's just very difficult to get them collared. So the colors need to last a long time and be underwater and all that. So the signals are just a tiny little beep once a second. Isotropic EMF surveys. So with the ever expanding need for wireless data, millimeter wave frequencies are starting to be used, and cell sites are moving down on light poles in the sides of buildings. And that puts the transmitters closer to people. And it's important to do studies per FCC OET 65. And you need to use the calibrated field strength equipment and make the measurements in line of sight. And now this isn't my drone. I'll probably use my Matrice 600 for this. I'll probably mount it differently. I don't like the long legs on this. I've had to land in the wind, and I don't think this would land well in the wind. But essentially, that's what's going on. You're using the calibrated equipment, and you're maneuvering around to get in the line of sight. Once of course, you know where you're trying to estimate the levels, you're in line of sight, you can then estimate the levels anywhere along that. So the advantage of a drone is that it can quickly move around and without having to bother people to assess the level that the people are being subjected to. The alternative is a man lift, bucket truck, and of course, doing that in an urban environment has its logistics. That's what people are doing today, and I think the drone can simplify that quite a bit. Flight logistics. Before I do anything, I make sure the landowner's okay with it. I've been asked to fly in parks, and of course, parks have radio systems, and they have issues with radio systems, and if they'll give you permission if it's to their benefit. So I've had that happen. The first thing is, is the landowner okay with it? Next, of course, is the FAA okay with it? Am I near an airport? Is there a reason that the airspace isn't right? Then you need to follow all of the visual flight rules. Weather, people management is a big deal. These are attractive nuisances, so you tend to get people coming over, and you really, for both FAA reasons and just you're pretty busy as it is. You can't have people just walking over to you, and I've had a challenge with that. My flights are typically very simple because I've got a lot of money on the aircraft. I know no reason to do anything stupid. I fly straight up, may position right above an antenna. I rotate slowly, watching the display, and then I come back down. There are some interference hunting tools that require you to maneuver around. And there are some wonderful automated flight tools now that allow you to simulate the flight to make sure you're not flying into a tree or a tower. So I may have to do some flying around a little bit, but as I say, I try to keep my flights down as simple as possible for both expense and safety. So here are the alternatives, of course, man lift. And I've been in a situation where it was a ski resort. They just didn't want that in there. They didn't want that running around on their terrain and leaving the tracks from it. So they brought me in to fly the drone. So they're slow to move. Of course, they can't go 400 foot in altitude. Disturbance of moving this vehicle up and down the roads. Certainly for the wildlife tracking, they've used manned aircraft. It's very expensive, and they're finding that the drones can do a lot. Of course, you have to keep line of sight, so there's a limitation of the drone, but there's a good advantage of drone relative to manned aircraft. Helicopter, the same situation, much more expensive, and they can hover, but again, and then mounting antennas on a manned aircraft, you have to be a lot more particular. You have to have approval for what you do there, and it's left up to the pilot for the drone to do that right. So a little quicker to maneuver antennas around on a drone. So huge expansion. I've seen enormous change in the industry in the last year. There are many new non-Chinese made drones. So that's going to solve that problem. So I think the value, I know my old coworkers thought I was crazy about trying to get a spectrum analyzer in a drone 5 years ago, and I think that's now proven that's an established thing to do, and it's going to be a big industry, and people will use that as a choice of, do I use a drone or do I use a man lift? So with that, I'll open it up for questions.
Great. We have a question from Mark Gibson. He notes putting external antennas on aircraft, put it in what's called an experimental category and making it a pain to fly. I guess that's more of a comment than a question.
Right.
There's also, you made a note, I guess back on slide 21 about the isotropic EMF. And
Right.
you'd shown an architecture that you thought was kind of ungainly, kind of awkward on the left there.
Yeah.
And you said you would probably fit one differently. What,
Yeah,
can you expand on that?
My drone's almost that big. It doesn't have the long legs. I would mount the same unit essentially horizontally, just like you see here. There's nothing wrong with that, with mounting it that way. So I would mount that analyzer on my pad. So it's I think this is around 9 pounds, 8 or 9 pounds, which is under my weight limit. And if we don't need to have the if for instance it doesn't have to go down to the ground, then I don't need anything else other than the equipment itself. It stores locally, and then bring it down to the ground and then monitor the results.
Great. Philip Voigt asks, can we address liability and insurance requirements and costs? He said he's seen this requirement on new contracts with the clients he's dealt with.
Of course, there's insurance companies that you need to have insurance for both aircraft and liability, and you buy that before you take any projects. I mean, it's just part of the work.
Yeah. Do you have a feel for the rough costs of licensing or getting insured before you come out?
I think it's I think I just got a quote of $350 for a month. And that's liability. That's not for your drone. If you want to insure your drone, and now they're not used to people flying spectrum analyzers that are $30,000. So you may have to have another talk with them if you want to insure that spectrum analyzer as well.
Right. Yeah. Well, you and I both know that gear gets darn expensive fast. Yeah.
Right. So yeah. That's so. Yeah, they're not used to that. So you'd maybe on your own for that.
Okay. So that's sort of, well, maybe that's for a future presentation, because this is only going to expand. So maybe we can frame out what costs might be, or maybe there's a rule of thumb. If your equipment costs X, the insurance is, X to a ratio of whatever, Y. And
I think you have to use good judgment too. If you look around, you see a lot of people, a lot of expensive cars on the street. You want to really think about that.
Yeah. That's right. Your old pickup truck versus your Lamborghini.
A lot of my flying, well, of course, I'm doing Virgin cell site work, and I'm not in the, if I hit a pine tree, that's it. I lose my drone. But you can get in an expensive environment, so you need to, as a pilot, you need to really think about it. Then there's gusts of wind. You've got to be careful with weather. And tower sites, there's guy wires that your anti-collision won't see. You may not see. So you just have to be really, really careful with these things. Yeah.
Well, that sounds like a whole nother area inside of the drone RF assessment area of, liability assessment and risk management. It sounds like you've got a lot of knowledge there, and maybe we'll end up expanding on that in further series. We have some more questions. Mark Lofquest wants to know, does command and control frequencies sending to and from the drone affect spectrum measurements, such as if it's a 5G Wi-Fi, can you not measure that band because of the command control? And also, have you characterized EM emissions from electric drive motors?
I haven't seen. I've worried about it, and I've tried to make a VHF. Of course, most of that motor noise is going to have a low frequency. It's going to be at the lower frequencies, not up at microwave. So I haven't seen it even at 150 megahertz UHF. And I think it depends on where you mount the antenna. So you can choose the antenna location, the receive antenna location to prevent. Of course, you'll want to, in any low noise, if you're down measuring a very small signal, you're going to have to filter to keep broadcast out of your measurements. So you're going to want to filter anyway. And I forgot the other. I think he's right that it currently most of the drones use the Wi-Fi spectrum for control, and I think you'd have well, you'd see your own signal. So you can still make measurements there, but you'll certainly see your own signal. I've done that.
So you just have to factor that and carve it out when you provide a report or whatever.
Right. Right. Well, hopefully, you know the signal you're trying to measure before you put the drone in the air. You know what frequency you're trying to measure. So you won't land on that because the drone won't fly if you're on top of that. So I don't think it's a big problem. You just have to know ahead of time what you're expecting to see and measure that spectrum only.
Yeah. Well, NSMA has developed, you know, we were created at the request of the FCC back in 1984. You know, for helping provide industry guidelines, you know, working with government and industry to provide guidelines, you know, in areas of development, as well as optimizing existing areas as they get more complex. So this might be something to turn into an industry guideline, you know, how to assess, you know, using doing RF spectrum analysis and calibrated antennas in a complex environment, including your own systems, right? So I think that's the heart of that question. Yeah. We do have a question from Jonathan Stefanik. Thomas, great presentation. Can you comment on progress being made on affordable LiDAR sensors for drones and personal opinions on use cases in this part of the industry?
Well, LiDAR is enormous. I think LiDAR is way ahead of wireless measurements, and they're being used regularly for tower inspections. So, and it's progressing very rapidly. I'm trying to just stick to doing the wireless stuff, so I haven't really looked into detail of what they cost. But I know my coworkers in the drone services industry are doing LiDAR work every day. So I think it's ahead of wireless measurements for drone applications, frankly.
Wow. Okay. Mark Gibson notes that, you know, regular aircraft are able to fly at higher altitudes. And have you had an opportunity to compare drone captured measurements with those taken from an aircraft flying at, say, 3,000 or 10,000 feet?
Well, I'd have to understand what the purpose of the flights are. If we're hunting for a whole herd of sheep over a portion of a state, I think a manned aircraft is going to certainly have a wider altitude is everything, right? Height above average terrain. So 10,000 feet is better than 1,000 foot. But if you're going to go get pictures, then the camera is going to get closer. I don't know. It's a trade-off. I think he's right though. I think altitude is going to help for some applications. It's going to help. Yeah.
And I guess you're going to want to be closer in if you're, trying to get RF measurements off a base station for.
Oh, of course. Yeah. That's not that's it. You'll get so many cell towers in that situation. You won't know what to do with all the data. Yeah. That's the other issue is that for cellular measurements, you probably only want to see one. If you don't want the whole industry coming into your spectrum analyzer.
Yeah, for sure. Yeah, right. Yeah, and there's I guess there's a couple cases where you're not going to want to have the whole industry in your spectrum analyzer, and then there's the other case where you're going to want to have it. And this is going to come up on a later panel, but I know you have some experience in this. And to get into it, for example, a lot of the human RF exposure measurements, the way the FCC rules fit, and be the circular 65. Rely on the notion that each contributor to the signal, 5% or more of the contribution in the event the signal, the cumulative signal is above the FCC standard, then anyone that's contributing 5% or more has a mitigation requirement. And, so in that sense, if you're measuring for a real estate development firm or somebody who's got a need, a requirement to take a broad look at a heavily installed rooftop or tower, then you're going to want to measure everything. Another thing is, and this is, again, something that'll come up in the later panel, but I know you know a little bit about this, is if these are in everyone's pockets or on the roof at the same time, they're part of the environment. So measuring that contribution, I don't know, I guess that'd be a pretty heavily laden drone or drone Air Force if you're going to start measuring all that. How would you start thinking about configuring that?
Well, you're going to know the uplink and downlink frequencies. So you'll be able to separate that NARDA piece of equipment shown in the picture there does frequency selective. So you could separately measure the level of the uplink and the downlink with that equipment. It does frequency selective measurements.
Do you think you could get anywhere from below 1 gig up to 40 gig with just one, or would you have to?
That one that you see there is frequency selective only to 6. It's not frequency selective above 6. So I think there will be frequency selective isotropic systems above 6. They're not readily available today, and they're certainly not flyable today. With a 50-pound limit. So you could do a good job 6 gigahertz and below, picking off uplink and downlink, but not above 6. You're going to get the aggregate.
So in the event somebody wanted to do all those measurements, there's some calibrated antennas and spectrum analyzers that go above 6. So would you outfit the same drone and just bring it down and bring it up, bring it down, bring it up, or would you bring a fleet over?
Well, you've got at the most 50-minute flight time, or with a load on it, probably 30-minute flight time, as you see there. Probably, I guess I would fly below 6, and then I'd fly above 6. I'd do 2 different flights.
Yeah.
And the above 6 equipment, since it's not frequency selective, is actually lighter than what you see there. That's an 8-pound or not 8-pound analyzer, the yellow one. The stuff that's isotropic is just diode based, so it's not very heavy.
Yeah. Are you seeing purpose-built companies that are doing this now, or is that is it still kind of a tailored, kind of a niche?
Not isotropic. For cellular surveys, I have, and certainly for broadcast antenna pattern measurements for repack, I see a number of people with kits for measuring the strength around the broadcast towers. But I think EMF is not as far along as those 2 applications.
Do you see a future where tethered drones are going to have longer flight time capabilities?
Oh, they do already. And there's, both of my drones could be tethered and stay up for 24 hours. That's just a choice. Of course, you don't have the maneuverability. So tethering is a different application. I think for spectrum monitoring, if you were an FCC, you wanted to see an intermittent, you would sit up there and wait for that intermittent and get the direction of it. So that is a great application for tether. I don't see tethering for EMF measurements. I can't imagine that scenario.
Okay. And to be clear, the tethering involves, you also have a wire that provides power.
It's providing power and not control, just power. Maybe there's a data link down. You might have a fiber down to the ground for data.
Okay, that's interesting. Yeah, data link and power.
Right.
So in terms of EMF measurement with tethering, I do know there are some persistent EMF sensing systems that are like rooftop borne that are coming out. So, because right now people go and, site safe or somebody with NARDA gear or Anritsu gear or Road and Shores gear or whatever. And again, we'll talk about this later, but they're mobile, rooftop tower, but mobile. But the persistent systems that are starting to coming to the market. I guess if you were going to have a persistent system on a drone or have it go up for a day at a time, how would you configure that?
Well, you're going to be under it. I mean, you're still, even if it's tethered, there's a pilot in command. He's going to have eye on the drone. So the pilot stays awake for 24 hours, or he has two pilots, right? So all the flight rules from the FAA still apply to a tethered drone.
Mm-hmm.
So you're going to be sitting there watching it go buzz while the data is coming down to the ground, and you're watching your data. You're looking for an intermittent, I would assume, then EMF. Yeah,
and then in terms of weather, obviously if there's lightning, I guess you're required to land, I presume.
Yeah, there's going to be all the normal flight rules, visibility and distance from clouds. There's all those rules still apply.
Yeah. Well, can't thank you enough. It's been an entire pleasure to see you, Tom. We're always amazed. I get a lot of comments, your activities, your innovation year over year. And it looks like this is only going to accelerate, not slow down. So
very fast. Yeah. I don't know if I can keep up.
Well, we'll have to get you to, propagate the propagators, train the trainers, and get a team of you out there. And as our environment gets more complicated, and we're gonna hear in other panels about spectrum. We've already started to hear about through Ira Keltz at FCC OET. Our spectrum innovation zones are being heavily funded, and there's just going to be a greater need to monitor and understand what's happening. From interference standpoints, human RF standpoints, just plain old creativity standpoints, new use standpoints. So. Yeah,
I'm on the drone special interest group for the Wireless Innovation Forum, and there's a whole bunch of there's a world over there too. I think I may be doing some field strength or small signal hunting around astronomy sites, radio astronomy sites.
Fantastic. Well, again, we thank you so much for being here. And, and again, as a reminder to everyone, all this gets posted on the NSMA website, and video as well as PDFs for constant reference. And I'd also like to mention that we're going to have the satellite mega constellation panel starting at 1. So there'll be a lunch break for everyone to get stretch their legs and have a good lunch, and then come back at 1 p.m. Eastern. And in the meantime, I believe Mariana is going to play one or more of our prepackaged videos that are NSMA specific. Thanks again for joining, Tom, and have a great day.
All right.
All right. Bye-bye. The National Spectrum Management Association, or NSMA, is a voluntary international association of microwave, radio, wireless, and satellite frequency coordinators, licensees, operators, manufacturers, and regulators. Established in 1984 at the request of the Federal Communications Commission, or FCC, the association provides a forum to develop industry guidelines for efficient use and management of the frequency spectrum by the wireless telecommunications community. NSMA provides a linkage between government regulations and industry practice by developing recommendations that streamline and standardize procedures used by the frequency coordination community. We strive to provide an open forum for stakeholders to mold responsible spectrum industry practice and resolve conflicts. If you know someone who should be a member, reach out and invite them to join. You can find us on our website, nsma.org, www.nsma.org, or find us on LinkedIn or Facebook. Thank you.
everyone. This is your NSMA President, Joe Sandry. I'd like to welcome everyone to our 37th Annual Conference. Although we're still meeting virtual, we continue to remain connected throughout our world of technology, and we're excited to present to you over the next 2 days this series of industry-leading talks and panels. Stay tuned to see the schedule. Enjoy the conference.
Hello, and welcome to the National Spectrum Management Association home webpage, where we provide leadership and guidance on today's critical spectrum management issues. Check in on nsma.org from time to time to see the latest developments and events. We have kept our conferences over the years carefully recorded in PDFs, and other archive materials can be found here at the bottom right-hand corner where you've previously seen other conference presentations. We would highly encourage you to look at them. There's a whole Trojan of materials on a variety of subjects. You can also learn more about our memberships here on our membership page at NSMA. You can become a member or renew your membership. On our sponsor page, you can learn more about sponsorship opportunities with the NSMA. We'd love to have you as a sponsor, so think about it. Here at the NSMA, we are always open on our webpage, so come visit us at www.nsma.org. If you have any questions, email us at info@nsma.org. Thank you.